Okay, then, if everybody can just get settled into their seats. I think we've got the speakers here at any rate, so that's probably good enough. That's all we need. So, well, welcome. My name is Tara Marshall, and welcome to the School of Biological Sciences at the University of Aberdeen. If you haven't been here before, we're really delighted that you turned out on an afternoon in November. We've got the housekeeping details to start. In case you hear the fire alarm, it's not a drill. We've got fire exits here and a fire exit there, so that's where you should exit as calmly as possible. Also, the fun thing is that we're recording this as a lecture, and it's live streaming, is that right? So, hello world out there. We've been coping with technical challenges all week, but it's been going very smoothly, and we hope more of the same. We are sort of tethered to the microphone, though, because the recording happens via the microphone, so that's why we'll be hopefully quite careful to pass microphones around. This format will be, we're going to have 5 presentations by the individuals who kindly agreed to participate in this event, and then that will be followed by a Q&A session. Because of the audio recording, what will happen there is that the audience can ask their question. The moderator, who will be my friend and colleague from Seattle, Paul Spencer, from the Alaska Fisheries Science Center. So he'll repeat your question because he'll have a microphone. And then we'll have to ask the panel members who will be seated up here, and they'll swap microphones across them to answer it. So it may seem a bit cumbersome, but we've all got quite used to it because we've been doing this for a few days now. And so anyway, I would like to acknowledge that the funding for this event is from Fisheries Innovation Scotland, and we have their executive director sitting up there. Hello, Cara, thank you very much. This is how your money's being spent. So we're delighted that they supported really a global workshop, and really the topic of climate change can only be addressed through global collaborations and global scale research, and that's what we've got going this week. We're having a week-long workshop. This is the public event that coincides to take advantage of the scientists who are in town for this workshop. But we've got 18 scientists from the UK, the US, Australia, Germany, Denmark, Canada, Norway, and Iceland. So those are all very strong fishing nations, and we're benefiting by those people having traveled long distances at inconvenient times of year to be here today. So our first speaker is Greta Petzel from the University of Tasmania. She's a world-renowned specialist in climate change ecology. She studies what's happening to the species in our oceans, in the warm waters in particular, and considers their impacts on food security. So we're delighted to have her kick off today's event.
Okay, thank you for that introduction, Tara. It's great to be here, and it's wonderful to see so many people here to hear about climate change and our oceans and fisheries in particular. As Tara mentioned, I'm from the University of Tasmania, from the Centre for Marine Socioecology, which is mainly about people and the sea and the connections between those. So tonight, or this evening, or this afternoon I should say, we're here to talk about fisheries and climate change. And because I'm first up, I thought we could spend a slide or two just reminding ourselves about why the oceans are so important. I'm then going to talk a little bit about how small differences can have really large biological impacts, and then about some of the changes that are happening around the world. And then we'll talk about why adapting to those changes is important. So the oceans are pretty central to humanity and health of the planet. They're 97% of the planet's water, 95% of the space that supports life on Earth, home to an awful lot of species, and they produce between 50 and some estimates are even 85% of the oxygen for the planet, and of course regulates our climate and our weather. So small changes, small environmental changes in that environment has pretty large biological impacts. But of course, our oceans are also important for a range of other reasons. So transport, shipping, tourism, commercial fishing, and human culture as well, obviously very important there. But tonight we're here to talk about fisheries, and fisheries employ around 260 million people in the world. So an incredibly important industry, and provides protein to around 3 billion people, or a significant part of the protein to 3 billion people in the world. So an incredibly important industry that we need to try and see how we can get some adaptation to climate change. And climate change is very much a marine issue. So the ocean absorbs 80% of that extra heat that we're worried about trapping in the atmosphere, and around 50% of that extra carbon dioxide goes into the ocean as well. So climate change is very much a marine problem. And so I spend a large portion of my time thinking about this particular pattern here, and it's not because I have a questionable taste in digital art or anything like that. It's because of what this pattern represents. Each one of these coloured bars is our annually averaged temperature for the planet from 1850 over here through to 2000s. And the blue is the cooler colours and the warm is the red. And you can see that that's a pretty stark change that we've had in a relatively short pace of time. So people talk about how the climate has always changed, and that is absolutely true, but we've not had this kind of rapid change in our history for as long as we've had life on the planet. This kind of change would normally happen over thousands and thousands of years. So another way of looking at that temperature change is this spiral diagram with months around there and warming as it goes out. I really like that image because to me, again, it shows how stark that temperature change has been. And as I mentioned, that 21st century warming that we've had is comparable in magnitude to the changes that we've had in the last 65 million years, but orders of magnitude more rapid. So we've got a 2-degree target that we're trying to achieve with the Paris Agreement, with that IPCC agreement, but so far our global agreements only get us to between 2.7 and 3.7 degrees of warming. So still a fair bit of planning and cooperation to go. But that temperature change that I just showed you has already led to some pretty big changes in distribution of our species. So as the environment warms, plants and animals in the northern hemisphere move north, and in the southern hemisphere move south. And that movement is much more rapid in our oceans. Plants and animals are also moving to higher elevations on land and deeper in the ocean. And those shifts are greatest where the climate has warmed the most. And I wanted to show you why even just 1 degree in temperature change makes such a big difference to our animals. And it's because of this kind of pattern. And I've got heart rate here with different temperatures along the bottom there. And you can see how heart rate responds to temperature. But heart rate here could be growth, it could be reproduction, it could be swimming speed. Almost any biological process follows this pattern. And you can see that there's a peak of performance there at around 24 degrees. We've only got to push it, in this example, 1 degree, and the capacity for that animal has halved. And this is a very typical shape to how animals respond to temperature for heaps of different biological processes. And that's why just 1 degree temperature in the ocean, which really doesn't sound like much, actually has a big impact on plants and animals and where they can live. And already if you look across the globe, you can see some really large changes in distribution. And this is really only a very small fraction of them on this map. But we wrote this paper to try and highlight how broad the changes are in terms of regions of the globe and types of species. And each one of those little points on the map there is a pretty big change in distribution with a big impact either in the human system or the ecosystem or climate feedbacks. Now, not all changes in distribution have a big impact on the ecosystem, but a lot of them do, and they can be impacts equivalent to invasive species. And the example that I've got here is a range-shifting urchin, a long-spined sea urchin, moving into the east coast of Tasmania, where I'm from, and the urchins eat the kelp habitat and turn it into this rocky urchin barren, which our main fisheries species in Tasmania, which is rock lobster, abalone and our reef fish, kind of don't like living in that urchin barren habitat. They much prefer the kelp bed for obvious reasons. So that's a pretty big impact that we're seeing off the east coast of Tasmania, just from urchins moving into the area. And we know that between 25 and 85% of species that have been measured are already responding to this change in temperature by changing distribution. So that's a pretty large proportion of our planet's species that we estimate are already changing distribution. Now, these shifts in distribution matter because of ecosystem structure and function, to food security. You can imagine if you're dependent upon a particular resource and it shifts, that's pretty important. Human health, so even pathogens and diseases are actually changing distribution, and that can have some impacts on aquaculture industries, for example. People's livelihoods, feed back to the climate system, and human culture as well. So there's a lot of reasons why these shifts in distribution matter. But of course, throughout human history, countries have battled over the access to resources. So globally, most conflicts are around either access to territory, or they're about ideology, or they're about access to natural resources. So as our fisheries species are changing from one jurisdiction to another, there's potential there for conflict, and that's something that I think we need to deal with at lots of different levels. Now, where I'm from is the east coast of Tasmania, and we're in a region that's in the top 10% for rates of ocean warming. So we have such a high rate of warming because of the East Australian current. That's a current that pushes down the east coast of Australia. You would have heard about that in the Nemo movie. And the East Australian current pushes down the coast in summer and it retreats in winter. But now we've got warming over the Pacific Ocean, in the atmosphere over the Pacific Ocean. That warming literally spins up the wind fields, which pushes that current much further and stronger down our coast. So we get a double whammy. We get the underlying warming that most of the rest of the ocean gets, and we have that change in current system. And that change in environment for Tasmania is really important for us and the implications of climate change. So we've got a pretty high rate of recreational fishing, including my daughters that love going out and having a bit of a fish. We produce the highest value of seafood nationally for Australia, and around a third of our agricultural production is seafood, and we've got some amazing, beautiful reef communities as well. But we have that high rate of warming. And for us, that's actually led to some pretty big changes. So I've mentioned the sea urchins marching down our coast. We've got a new octopus species, that's 13% of our octopus fishery now, in just under a decade. A whole lot of intertidal species also moving further south, and dozens of fish species have also changed distribution off the east coast of Tasmania, and then seaweeds as well. So that's our habitat forming organisms changing distribution, which obviously then impacts the rest of the species. And if you put all that together, our east coast looks pretty different now. So pre-warming, we had lots of kelp, large populations of rock lobster and abalone, and now obviously it's not quite that stark all the way down the coast, but it's a pretty different environment that we have. So it's a fair question to ask, how have our industries adapted to that? And so we collated what information that we could find on how our industries were changing their practices. So that's what I mean by autonomous. So how were our different fisheries industries changing what they do without any management interference or help from the government? And we found that there were charter operators advertising for some of these new species. There were lots of changes to product handling and landing practices, lots of changing practices for our aquaculture industries, and lots of examples of industries using seasonal forecasting for farm management. So already our industries were really quite adaptive. We're also undertaking some research trying to identify how can we as researchers try and help some of our industries adapt. So we've been producing forecasts of habitat, what sort of habitats are suitable for particular new species coming into areas. This one here is yellow-tailed kingfish. It's an incredibly popular recreational and commercial species. And so we were trying to calculate at different 5-year bins, so at timescales relevant to fishing industries, how much the habitat might change for that animal, and calculating what might be declining fishing opportunity in parts of the range, and then what was the increasing fishing opportunity in terms of months per year. So we were trying to collaborate with our industries and come up with some information that was useful to them. And I really think understanding and responding to these climate-driven changes really does need all hands on deck. It's a massive issue throughout the globe, and I think the more that we collaborate with different industries and with the public, the better we will be. An example that we have from Australia is this citizen science program called REDMAP, or the Range Extension Database and Mapping Project, and members of the public all around the coast send us photographs of species that are unusual, so species that are changing their distribution. So we're getting a lot of help from our public to help identify what some of these changes are. So just to finish up, I think that all countries and fisheries will ultimately be affected by climate change, but those industries and those regions that are trying to understand the climate change risks and adapt will really be ahead of the pack. And I think that our understanding and our capacity for adaptation will be much stronger when we all collaborate together. So scientists, industries and the public trying to work together to address some of these issues. So thank you very much for listening, and I'll look forward to questions later.
Okay. Okay, our next speaker is John Pinniger from what I call CFAS, but its formal name is the Centre for Environment, Fisheries and Aquaculture Sciences. Okay, he's director of the Marine Climate Change Centre, and he plays a strategic role in developing research initiatives and adaptation strategies within the UK. I think of the guy in the hot seat, literally, and maybe figuratively. So welcome, John.
Okay, thanks very much. Tara asked me to give a similar talk to the one that Greta's just given, but from a more UK perspective. So climate change can affect fisheries and fish in many different ways. Often we think about it can cause the relocation of the resources, so the fish and then the fisheries that follow them. It can change the timing of events like spawning events, recruitment, migrations. It can affect the overall productivity of the fish stocks. So particularly if the plankton at the bottom of the food web changes, it can make the fisheries themselves either go up or down. It can affect storminess, and I'll show you some examples for the British fleets of how storminess can be affected. And then recently there's been quite a lot of work on ocean acidification, where the CO2 that's released into the atmosphere as a result of industry and travel and all that sort of stuff, a lot of that ends up in the ocean, and the oceans become slightly more acidic. I'm mostly going to talk about distribution in this talk today. Oops, there we go. One of the biggest issues that in the UK that we've sort of had to deal with over the last few years has been mackerel. Mackerel is by far the most important fishery species up here in Scotland. It's key for the income of the industry. It's 43% of the total value of the fish landed in Scotland. And over recent years, there's been quite large changes in the distribution of mackerel. Both are sort of spreading out to the north and particularly to the west, towards Iceland and the Faroe Islands, and also away from the North Sea sort of sector. And this has had all sorts of implications in terms of politics, in terms of quota agreements, and I'll hopefully have a quick run through some of those. So this little infographic over here shows basically what's happened over the last sort of 5 or 10 years. In 2006, mackerel was first observed in significant amounts of Iceland as a sort of bycatch in the spring spawning herring fishery. And not unreasonably, Iceland had it around there themselves. They didn't really have that much of a fishery previously for mackerel, but it's in their waters. They felt that they should exploit it. Because the way that the quotas work in Europe, they didn't previously have a share, but Iceland there is not part of the EU, and they can declare their own quota. So they declared 150,000 tonnes. Then the Faroe Islands followed it. And so if you can read that little infographic, it says, August the 10th, 2010, Iceland allocated itself a new quota. By 17th of August 2010, Faroese fishing boat the Jupiter was prevented from offloading here in Scotland, in Peterhead. By the 2nd of December 2010, officials from the EU, Norway and Iceland and the Faroes failed to come to an agreement over the quota shares. By December of the same year, Iceland announced the quota of 146,000 tonnes. And basically it carries on, and for the next 5-10 years there was no real agreement over who should be allocated those quotas. And so this sort of illustrates that when species move over these political boundaries, it can cause absolute mayhem about who is allowed to exploit them, what is a fair share. And that movement of mackerel over this period, which I'm sure some of the following speakers will talk a little bit about, some people have said it was due to warming waters, and there's a nice paper by Scottish authors that suggested that it was about a 35-kilometre move for every degree C that the temperature changed. Other people have said it was due to food availability or to density dependence. So when the stock was high, it spread out into the wider North Atlantic. It's a very complicated picture, and it's not really clear, but it did flush out some of the problems that you get when species move their distribution. Another one that we're seeing recently is squid. So squid, they've always been around the UK, but one thing that we've noticed from our trawl surveys that we do every year is that they've increased in abundance and in their spread. So in the trawl survey that CFAS runs in the North Sea, back in 1984 they were only in 20% of our stations that we survey. By 2014 they were in 60% of our stations, so they're definitely spreading out. And it seems to be very, very tightly correlated with climate, as well as several other variables. And in recent years there has been a newish fishery operating up here in the Moray Firth, particularly in the summer. Although largely fishermen are engaging in this because they've got restrictions on the other species that they would traditionally have caught. But this is another example of where climate and changes in the distribution is changing what fishermen catch, changing what they target, and the way that the fisheries are developing and will develop in the future. At CFAS, we're quite lucky. We're situated in an old Victorian hotel that we've been in the same building for about 50 years, and we sit on a sort of raft of rotting paper. And that includes, the map on the right-hand side there is one of 37,000 charts that we discovered in the basement. And what they show, the upper number there is the catch of a particular species, probably cod, and the bottom number is the number of hours fished. And we have this going all the way back to 1902, but in a proper form from 1913, right up to the present. And what we've done is we've digitized that data to look at where the center of the fish catches now sits. So where are the peak catches of the different species? So this is for place, 100 years of place, and these are by decade here. So 20s, 30s, 40s, 50s, 60s, 70s, 80s, 90s, 2000s. And you can see that for most of the 20th century, place were really distributed in the south of the North Sea, sort of off England and between the Dutch coast and the Danish coast. And it didn't really move very much. But in the last sort of 20 or 30 years, you can see that place have moved towards the centre of the North Sea and also around Scotland as well. And you can express that in a number of ways. But if you look at the centre of gravity of that, over the whole time series, you can see that they've moved generally from the south towards the north. They've also, for some strange reason, over the last few decades, they've lurched towards the west. And they've also moved into deeper water. So this correlates very closely with temperature, but also with fishing pressure. And so we've done this for about 5 or 6 species. Some of them move north, some of them move east, some of them south. But there's various climatic reasons why a lot of these changes have happened. Similarly, cod, if you look at the figure on the right there, cod have been mostly distributed throughout the North Sea and fairly static for most of the 20th century. But I hope you can see the last two panels, that in the last sort of 20, 30 years, they've really retreated up into the deeper parts of the Norwegian Trench and the northern North Sea. There was quite a nice study in 2005 that did some projections into the future, and that suggested that the cod would disappear altogether from the Celtic Sea, that's the area south of Ireland, and the Irish Sea by about 2100, and that it would decline in the North Sea as well, but it would still remain in the North Sea. Then there was a study by people from Marine Scotland, just down the road, suggesting that the yield of the cod has declined by about 32,000 tonnes per decade since 1980. But the sort of take-home message of that, for the North Sea at least, is that the North Sea can still sustain a cod stock in the future, but it may have to lower the level of fishing that we can exert on it. So the carrying capacity, if you like, for the fishing industry is lower now. Another strange one that started, taking us a bit of surprise actually, we're getting a lot of telephone calls about this at the moment, is bluefin tuna used to exist in the North Sea. They kind of disappeared in the 1970s. There was a little recreational fishery off Scarborough and Bridlington, but then they completely disappeared. But now they're showing up in quite big numbers, particularly on the south coast of England, and we're getting a few on the Scottish coast as well now. They're of interest to both commercial fishermen and to recreational fishermen. They're managed by something called the International Commission for the Conservation of Atlantic Tunas, called ICAT. At the moment, the UK has no quota for this, so if fishermen are landing these, it's illegal. Whether it's recreational or commercial, it's not legal to land these in Britain at the moment. But they are increasing in number, and it's going to be quite a big issue. Okay, so that was talking about the sort of things that we've already seen. We've done quite a lot of work over the last 10 years or so trying to predict where the species will go in the future. And we've used a number of different modelling techniques to do this, particularly what are called species distribution models or niche models, and a lot of them are sort of correlative. So you look at where the species is distributed now and how that correlates with the environmental conditions now. If you can predict the environmental conditions in the future, you can predict where the species will move to. And so how this works is we have data sets of where the species have been observed, the presence. So that's what we have here from ICES and databases like OBIS. We have data layers of, in this case, temperature, salinity, and depth. And then we can match that up to produce a habitat map of suitable habitat. And then we can do that now and into the future. And when we do that, we can look at the projections for whether the species is going to move north or south. And in most cases, it suggests that the species are going to move north, particularly in the North Sea. So this is the latitudinal central with latitudinal distance north. The green line is 0, and you can see that pretty much every species there is predicted to move north. Actually, the pelagic species, things like herring, are predicted to move faster and further. They're not on this particular plot. Overall, if you do that, you get winners and losers in terms of if you're sitting where we are in the UK territorial waters. So the ones that are predicted to be winners, if you like, are things like squid and sea bass and pilchard or sardine, sprat. So these are all warm water species that most people traditionally think of as Mediterranean. Whereas the more traditional species like cod and herring and plaice are predicted to overall be losers. They'll still be there, but less so. The one thing to notice from this plot actually is that we used a whole range of different models, and some of these span from minus to plus. So that shows that we're not sure whether they're going to be quite winners or losers. Some models are predicting that they might win slightly, some that they might lose. And so you have to be a bit careful with these projections. And it shows why no one model is true. It's best to throw every tool you've got in the toolbox at it and look at, hopefully, the robust things that come out in the middle. A few years ago, in the UK, we have a Climate Change Act that requires that we do a risk assessment for every industry in the UK every 5 years. And as part of that, we did a report with an economics consultancy looking at what can the industry do to capitalise on these winners, these species that are going to come into the UK waters. So we used the modelling results that you've just seen, and we tried to work out, well, how can the industry adapt? And is there a case for government to intervene, or is it something that the industry will just adapt to? So there's a number of key adaptation actions that were sort of proposed both by the industry themselves in workshops and through the government researchers. Firstly, fishing boats can travel further to catch the species that they're traditionally used to catching, things like cod. We know they're moving north. Fishermen can follow it. They can diversify their livelihoods, whether that's going into other industries or changing the species they're targeting, or even leaving the industry, or going into recreational fishing. They can increase the vessel capacity to target species that are on the increase rather than the ones that are likely to decline. And in the UK, we've had various programs where scientists and fishermen have worked together to teach each other how to either assess or to survey different populations. They can change their gear and target different species, and I'll show some examples of that. And finally, there's a need to develop new routes to export markets and to expand the domestic market, and I'll talk about that as well. In the UK, we're kind of weird. Basically, all the fish, or a lot of the fish that we eat, everything you pretty much get in the fish and chip shops, we import. Most of the cod and the haddock comes from Norway or Iceland, and we've been doing that since the 1930s. But most of the fish that we catch, mackerel and langoustine or scampi, we export to places further south. So we're getting our fish to eat from further north, and we're exporting all the fish we catch to places further south. That's kind of maladaptation to climate change. We should be really trying to eat things that live in our own waters, or I think anyway. And so there have been campaigns to try and get people to eat things that live around the UK. So this is Hugh Fearnley-Whitting's stall, trying to get people to eat the mackerel bap. He wasn't terribly successful, but it was a good try. This is Jamie Oliver, working for Sainsbury's, trying to get people to switch the fish. Trying to get people to eat sea bass. Actually, sea bass is in a terrible condition at the moment. Don't eat sea bass at the moment. Again, there's lots of these sorts of campaigns just trying to make us think a bit about what we're eating. And yeah, try and be a bit more adventurous on the sorts of things that we eat. A lot of these things taste really great. A few years ago, we had a project where we sat down with fishermen and talked about climate change and changing temperature and all that sort of stuff. And for a lot of the fishermen that we spoke to, they weren't actually that interested. But what they were interested in was storminess, particularly the beam trawlers and that part of the fleet. In 2013, 2014, we had quite big storms, at least over the southern coast of England. Many vessels were tied up in port for about 3 months. There was quite severe damage to some infrastructure, some harbours, and fishing remains the most dangerous occupation in the UK. It's about 115 times more dangerous than being an office worker. And so, understandably, fishermen are interested in storminess, or most fishermen. There was quite a lot in the press during that time. Yeah, these are some of the images. Yeah, you can find loads of these sorts of press clippings on the web. So what we've started to do, I've got a PhD student who's working together with the insurance industry to look at the conditions when fishermen stop fishing. And so what we have here, these are the weeks of the year, and on the left here is the wind speed for 2014. And you can see that there's a sort of a peak in wind speed here in week 6 when it goes above about 10 to 15 meters per second. And during that period, there was basically hardly any fishermen out. And we're trying to develop a model that models how fishermen will respond to weather, and whether they listen to the radio to get that information, do they just go outside and put their finger in the air and say, I'm not going out in that. It really depends. Some fishermen have a lot of risk appetite and will go out in anything. Some fishermen won't. But what this is showing here, this is week 6 of 2014, the height of the storms, and this is week 5, the week before, and I hope you can see that there was a lot more fishing here the week before, and a whole sway has disappeared. They were all in port. And so, as I say, we're trying to model that now, and so then develop models that we can project into the future. And the reason we're doing that is, actually the climate models are absolutely rubbish for storminess. But But what they are showing is that the projections for the UK, at least, are that we're going to get more regular high wind speeds. So there will be bigger sort of high magnitude storms in the future. This is from global climate models and regional climate models, and it's pretty robust, this particular projection. So we should be interested in storminess as well as temperature. That was all I was going to say on the UK. I'm part of a project as well called CERES, which is looking at climate change implications on fisheries and aquaculture throughout Europe. That's my email. And yeah, thank you very much.
Okay, our next speaker is Alan Haney from the Alaska Fisheries Science Center in Seattle. He's a very unique species. He's an economist, and he's investigating how climate change can impact biology, but also market conditions that impact, in particular, the Alaskan fisheries. So he's going to talk about some of the strategies and ideas floating around in the world of economics.
All right, thanks, Tara. Thanks, everyone. Thanks for coming for an economics talk late in the afternoon. I've worked on trying to model how fisheries respond to all sorts of things over the years, but over the last decade or so, really been focused on climate change. And this project that several other people here are involved in, the Alaska Climate Integrated Modeling Project, is a project we've been working on for a few years that really, it's led by Ann Hollowett and Kirsten Holzman with a number of other PIs, and the idea is to take some of the things that we've learned over the last decade and put them directly into fisheries management. So trying to talk to people in industry and learn what their primary concerns are. I work here in Seattle at the Alaska Fisheries Science Center. A lot of the research part of NOAA that's focused on Alaska is based in Seattle. And we work with the North Pacific Fisheries Management Council. So we're NOAA, but the National Marine Fisheries Service, or NOAA Fisheries, is both a management agency and a scientific research agency. And together we manage the federal fisheries of the United States. And the council, it's really a great process in that the governors appoint members of industry and communities, as well as their government representatives that sit together and work on policy. So it's a way that we repeatedly have interaction with stakeholders to communicate about fisheries management. And it means that when a new policy is put in place, the public has a number of different opportunities to comment on it and to have ongoing interaction as we develop new actions or change our direction of how we use science in the process. And we also, in Alaska, the state of Alaska also manages some fisheries and conducts research on those fisheries, so we coordinate with them as well. And so there was this big project that started in the mid-2000s, but mostly ran from 2008 through 2014. It's called the Bering Sea Integrated Ecosystem Research Program. And it's about 100 scientists and lots of involvement with native communities and fishing communities. And basically we realized that climate was impacting the system. And so we tried to say, okay, what are the things that we need to know to look forward to be able to better manage our resources? And so really there were ships that went out and did basic science. I was an economist involved in this process. There were anthropologists involved in trying to understand how native communities were experiencing environmental change. Lots of different biologists. It was an integrated ecosystem model. We had all these things that really taught us a great deal. But at the end of the project, we said, okay, let's make sure that we're actually using this in our management process, at a process that's really worked well in Alaska to manage many of the most valuable fisheries in the United States. But this key question is, right, we know that there are big changes happening. Can we use this directly in the management process? And so the goal here has been to make long-term projections but then to really focus on how do we use those in the short term to adapt in the way that Greta and John both spoke of. And so we're projecting ocean and fish populations as well as socioeconomic change out for a century. And in some cases, we can't do that. We can't do that about everything, but we can see the way that different changes in the environment are likely to impact different species and get insights from different types of models about the types of management choices that we can make now and over the coming decade to do things better. And a key part of this project has been having you saw that big group of people that, I don't know, are there any economists here? No, yeah, right. Myron on, yeah, right. Myron on weekends and tax days, maybe. But that's really a key thing is having these interdisciplinary teams, because the nature of these problems is that you can't think about this in one discipline. And so this group, we have lots of contact. We get together at least once a week and talk about the way that the oceanographic elements of the project fit together with the biological, the economic, and social. So, and we had this history of working together, and I think that this is a key thing. I want to emphasize in how I think that we have to do this type of research. You can't think that you're going to show up at a panel like this, understand everything, go home and solve the problem, or even a workshop. We're having this great scientific workshop all week, but really it's a longer term process where you have to communicate in an ongoing way. So I want you to start right now. So turn to the person next to you and say, hi, my name is Alan. I'm an economist from Seattle. Don't say that, but say who you are. Yeah. All right. See, now you're all economists. Yeah. So I think, that wasn't so hard. But that's the key, really, is that you've got to get out of your comfort zone and push yourself in new ways and think about the way that your work connects to the other pieces of the system. And I think that's a key part of this for us is this last idea of connecting. Don't think that you can stay in your own silo for a while and then 2 years from now you've figured everything out, put it together. Integration is a key part of the process, and it's really an iterative thing that you've got to do again and again. In a similar way to what John and Greta talked about, this is it's Alaska up here. This is from last summer. We've had these really warm conditions, and a big part of the impact of that in Alaska is ice is a big part of our ecosystem. It drives all sorts of biological action, and this last year was a record low in ice. So we're having many types of extreme events. We've had a couple of large heat waves in the Gulf of Alaska. There's a cod fishery in the Gulf of Alaska. It's not as large as the Bering Sea cod fishery, but this year, the quota was cut 80% after a big heat wave that killed several year classes in the fishery. So we're experiencing the impacts of climate right now, of climate change and extreme events now. Something that I've worked on, so this is kind of shows you some of the ways that economists might think of things differently than biologists or oceanographers. So the upper right is where we are in the Bering Sea in Alaska. This lower left map, the blue area is the presence of the cold pool, the presence of cold water after the ice melts in the spring. So the dark blue is a cold year, and the light blue is a warmer year. And what the right side shows the average fishing location, and the bottom, the red dots are the winter fishery, and then up further to the north, different years for the summer fisheries. And what we've seen is that the pollock and cod avoid the cold pool. It avoids cold water. So in the colder years, actually fishing was relatively good in the north. So we saw sort of the opposite pattern of what we see when we look at the biological survey data, where in that case the species are shifting to the north. But across this decade, actually, a lot of fishing happened in the colder years in the north because the fishing was so good. It was concentrated So it's the interaction of the fish in the cold water that led to the fishing conditions and how fishermen were choosing to fish in different locations. But then in the lower right, it's the winter fishery. The roe-bearing fish there and the spawning grounds haven't moved, so that hasn't shifted at all. So it's really important to think about these economic dimensions at the same time that you think about the biological dimensions. And this is the sort of total picture of this Alaska Climate Integrated Modeling process. So we have different global climate models that say what will happen if the atmosphere warms by different amounts. And then that's connected to the physical models of how the regional ocean is going to warm. That then connects to biological models. And then we can think about this socioecological system, about the way that fisheries are responding to that, about how communities are impacted by those fishery changes, and then the role of managers in helping to minimize the impacts of some of these changes. And when we run these different models, we see this is just the summer bottom temperature, see pretty different conditions. There's a lot of uncertainty here about what's going to happen. And we're not going to be able to give a really clear answer, like this is what's going to happen next year or in a decade, but we can think about scenarios and putting together different models that will give us insight into how we can best handle things. So as part of this model, we have this group part of this project, we have this group of models. And so most fisheries are managed with single species models. And we're able to think about the way that climate impacts a particular species, mackerel or hake or pollock. And then we can also think about the way that those species are impacted and that they eat each other differently, put a few species together. And then we can think about food webs in different ways. And so none of these, the single species representation of the ecosystem is overly simplistic, but it also doesn't have all of these complications and pieces of information where we don't understand. We understand those pieces better. But we put this all together, we can get different levels of insight that collectively, in the same way that with weather forecasts and hurricane forecasts, we take groups of models and get better predictions. This can give us a better sense of how the whole system works. And we can then couple that with different economic models. So we just, in some cases, just look at an effort response of how many fish are going to get caught. And then more complicated spatial models that take into account the things we know from fisheries and the long-term analysis of data. And then we can look at how that impacts different communities. And a key piece of this for us is trying there are all these factors that when we look forward, we don't know what fish prices are going to be in the future. They may go up or they may go down. Expensive fish a premium for that as there are more wealthy people in the world may go up. But at the same time, there's a demand for raw protein in aquaculture. And there are different prioritizations of conservation that may go down. So we can package these in scenarios that we don't know the particular answers, but we can understand the key dynamics that impact what's happening. And so we're running all of these models, and we have sort of draft results now, but we're refining those and integrating those now to put in papers this year. But kind of the simplistic thing that we've set up is just we have a simple, no fishing run through these models that lets us isolate the impact of climate. We have our current system. And then we can shift in our system a couple of different ways that are the realistic way in which we manage the fisheries towards catching more pollock and cod or catching more flatfish. And that lets us see what are some of the possible dynamics given the things that we know about how the system may change. We've talked to fishermen a lot and other people in the industry, and a key thing that comes up is this idea of too much rigidity. When the fish are shifting, there's a feeling that the rules that are in place that aren't flexible enough to allow us to take care of opportunities that may present themselves, or the fact that someone may not be able to target their traditional species. And so we're really working with industry to think about, okay, what are the things we need to protect? Because there are reasons why those rigidities exist, but can we make the system more flexible so that we don't have unnecessary rigidities, and we have a system that's more flexible as the environment varies more. And so we're looking forward, looking at, okay, how are the types of management elements that are part of the North Pacific that exist now, how can they change to encourage more flexibility and at the same time achieve the types of protections that we like. So we're working on a key piece is the revised harvest control rules of trying to assess, all right, given the things that we're learning about how climate's impacting different species of fish, what does that mean about how many fish we should catch under different conditions? And so, key things, the system's changing. The tools that we're developing, we're not going to have all the answers. We're building the framework, and I think this is something to really encourage people to work on, is to think for you, okay, what's the framework of your system? You're not going to have all the answers. You may not know pieces, but you can see what you know and use that better, and then really identify what your main challenges are. And management can help us a lot. There's been some good work done all over the world that basically, climate is going to shock our system in different ways. But if we make our management system a lot better, the impacts of that can really be greatly reduced, or in some cases, there'll be benefits that we didn't have before that we'll be able to take advantage of. And again, I think interdisciplinary science is a key piece of this, of trying not to think of our own narrow view of the world, but trying to reach out and have long-term relationships and engagements in different fields. So, thanks.
Your turn. Okay. Okay, our next speaker is George R. West. I'm using your middle initial because I've been told how many George Wests are there in Scotland?
There used to be 4 in our street.
So this is George R. West. He's the skipper of the pelagic trawler Resolute. He's been fishing in Scottish waters for 4 decades. Hard to believe. But anyway, so he's here today to share his ideas about fish distribution in Scottish waters with an emphasis on pelagic species such as herring and mackerel.
Well, good afternoon, ladies and gentlemen. When I was approached about giving this talk, I was perhaps a little hasty with my agreement, I feel now. As I do feel a bit like a fish out of water, if you'll excuse the pun. I think I would prefer a rough day at sea. But nevertheless, here I am to give what I've called a fisherman's observations on changes in fish distribution. And they are just that, a fisherman's observations. It's not about prediction, it's just about what we have seen, what I have seen over the years, over 44 years actually. I've been a pelagic fisherman for 44 years. My father, grandfathers and great-grandfathers were fishermen too, and my son now skippers the family boat, and he has 2 sons who may one day wish to go to sea as well. So I am very interested in what may happen to our fisheries in future as a result of climate change. And although I'm almost retired from sea now, I'm still very much involved with what's going on out there. The story is told of a young Scot called Jock, and I've heard it repeated recently. It was in the Herald in relation to our present Prime Minister. And the story goes that Jock joined the army, and at his passing out parade, his mother was heard to declare proudly, "Would you look at that? They're all out of step except our Jock." I fear you might think that after I'm finished that I'm a bit like our Jock, but what I have to say is an honest assessment of our fisheries then and now, then being 40 years ago and now today. And as a pelagic fisherman, my career has been mainly focused on catching herring and mackerel, and I'll restrict my observations to those 2. Beginning with herring, because that's where I began. When I left school in 1974, age 16, I'd already spent a couple of great summers catching herring in our family's wooden purse seiner in the waters around Shetland. And the wisdom passed on from father to son at that time was, go to the west side of the Shetland Islands, up here. Yeah, I don't know if you can see that pointer or not, I hope so. For bigger, stronger herring, and to the east side of Shetland, in this areas, for slightly smaller and more delicate herring. And as summer progressed, we fished more south and east of Somber Head and east of Fair Isle in this area here. That area east of Fair Isle was renowned in those days for a soft herring that were full of red feed, and that was difficult to keep well preserved for the market. The fishing areas east of Orkney, in this area here, had that same reputation for smaller herring again and a soft herring. Whereas the fishing area west of Orkney, in this area, the herring were more like those in the west of Shetland. It wasn't until many years later that we actually followed the shoals all the way from the northwest of Shetland up here down to the northwest and west of Orkney. So it was actually the same fish, or very similar fish, that were travelling down there. As I mentioned earlier, we were purse seining at that time, and the vessels and the fishing gear and equipment we were using made it very difficult for us to fish in less than 45 to 50 fathoms of water. So the areas we focused on for fishing herring were the deeper waters earlier in the season, before the herring went into the shallower waters to spawn. However, there was at that time also a large fleet of pair trawlers who could access those shallower waters, and they started fishing later in the summer, beginning around the 1st of August, and they were focused more on the shallower banks for herring that was close to spawning, and those areas ranged from Copensay Island, here on the east side of Orkney, down to Caithness on the Caithness coast, and down off the bank on the banks of Fraserburgh and east of Peterhead, even down off Aberdeen. And as the summer progressed into late summer, then they would move south to this area, northeast bank of Longstone Island, and even further south down to Scarborough and Whitby area. So that was a fishing pattern 40 years ago, where we found the herring, long before we had ever thought of global warming and its consequences. And if you know anything about the history of the herring drifters in the early 1900s, you may recognise some of those places I've mentioned being mentioned even back then. So that's the situation 40 years ago, but what do I see different today? In truth, very little at all, actually. We return to those exact same areas year after year at similar times, and although it varies a little from year to year, sometimes they're a little earlier, sometimes a little later for reasons known only to themselves, they just keep returning to the same areas. The herring on the west side of the islands still tend to be stronger and have less quality issues than those on the east side, and which still tend to be softer and full of feed. Over the years, what changes have I seen? Over the years, we have discovered herring in areas we've never fished in before, but I suspect that's more to do with the fact that we rarely looked in those areas because we couldn't fish there. And now we have better equipment for finding and catching them in those areas. Stock seems to be in good health, and little time is spent these days in searching for herring, so we just keep returning to the same areas we've always done and finding herring there. One thing I have noticed is that it does seem to be that we find less, or we see less of the red feed I mentioned earlier, both in the herring and on the water surface. Sometimes years ago we could see patches of it on the water surface, like a semi-translucent layer, red layer on the surface. It was almost like red diesel spilled on the surface of the water, and I don't recall seeing that in recent years. Is that an indication of change in the plankton? That maybe that's not really my area of expertise. The other area we fished in for herring was the west coast of Scotland, and in the Minches, that's in this area here. These are the Minches, North Minch and South Minch. We fished in those areas, and it's more difficult for me to make a judgment in those areas of changes because there has been so little fishing there in recent years. Traditional fishing there was focused in the sea lochs and around banks that we would find very difficult to access these days with the type of vessels and the fishing gear we now have. Added to that, there are many fish farms in the sea lochs, and there's a huge expansion of creel fishing all over the west coast, which makes access difficult because of gear conflict. The creel fishermen get very upset if we come in with a trawl and take away all their creels and the catch that's in them. So that's another restriction. Another difficulty is distance from the market. The market is all on the east coast in this area or up in Shetland. So you can see the distance from here to the market is considerable, and so we tend to fish in areas that are closer to the market. However, although we're not doing much ourselves there, the pelagic fleet is working hard. The fishery is closed at the moment because of some uncertainties around the science, and the pelagic fleet is working hard to help scientists increase their knowledge of the west coast herring through surveys and sampling, but it is a huge area to cover, a big job. But we have to begin somewhere, and we have begun, and hopefully that will bring results in the future. However, although we're not there very often, we do get reports from some of the smaller Nephrops vessels that are working in the west coast of large shoals of herring in areas we fished in 40 years ago. And you may recall earlier this year there was a report on TV of divers that were working in the Minch. I think it was around this area here, around the little town of Gairloch. These divers came across a large area of herring spawn that they hadn't seen before on the seabed. Another occasion, a pelagic vessel one of our pelagic vessels was carrying out a survey of part of the west coast last winter and found another large area of spawning herring further north off a little town called Melvig. That's exactly where the boats fished them 40 years ago. So I suspect that although the west of Scotland herring stock seems to struggle for some reason, they are to be found in the same areas as before. So again, I have to say, from the evidence we have as fishermen, these are just our observations, there is not a great deal of change in fish distribution. There may be a change in fish quantity. So mackerel is the other stock I mentioned. Mackerel fishery has been very, very different. Mackerel fishery began in earnest in the late 70s with the advent of high-frequency sonar and echo sounders, and up until that point we couldn't see the mackerel, so we just didn't know anything about mackerel. And with that equipment coming on board the vessels, a whole new world of mackerel opened up to us. The early years of the fishery in Scotland were conducted in the Minches during late summer and autumn in this area, up and down this coastline. They migrated from north to south through the Minch. We usually picked them up in this area, and they migrated down through here. We suspected some of them went inside the Isle of Skye and some outside. And then they disappeared down into the southwest before they appeared with the Irish fishermen off the Irish coast. That's how it all began. But almost from the start, it seemed that each succeeding year their migration route moved further and further northeast. It soon moved on to the north coast, and then it moved off the north coast, and the migration went down on the outside of the Hebrides, went further north again, and went further outside the Flannan Isles and St Kilda, and on down to the Irish coast. And this pattern continued in a north and northeasterly direction, always returning to the southwest. And we used to joke in the early part of this change, we used to joke that if this continued, we would soon end up in the Norwegian sector. The humour was short-lived, as we soon realised that's exactly where they were heading for. And I think it was about 1994 or 95 that we found that the mackerel were foully encamped in the Norwegian area over here, no, further east than that actually, well maybe in that area, yes, in that area, for the whole of the period from October to late December. It was a difficult time for us because of course we didn't have access to the Norwegian area, and that some of the things that some of our earlier speakers talked about, the difficulties of access because of existing rules. So but we survived because each year, without fail, at the end of the year, December, early January, the mackerel made a mad dash from this area in the Norwegian sector across the north of Shetland and hit the edge of the continental shelf and made their way all the way south to Ireland to the spawning areas, way down under the chair there somewhere. The most extreme point of this changed route was taken by the mackerel, and that was that took them into an area of 250 fathoms of water off the edge of the continental shelf. We were towing in that area, in that depth, and that continued all the way south. So quite a change from being hard up against the coast to being out there on the edge of the deep, the Atlantic deep. And we wondered then, what is the next step? Where else can they go? Where else would they go? Well, the next change was perhaps the most unexpected one. Gradually, over the last 10 years or so, that pattern has completely reversed, so that now, today, the mackerel appear in Scottish waters east of Shetland in October, and they move south until they were as close as 50 miles from Fraserburgh. That's about this area here. Then they seem to turn and go northwest through the gap between Orkney and Shetland, and at the moment they're firmly encamped in this area west of Shetland inside the 12-mile limit. So it's quite a change in the opposite direction. And of course they still make the long journey south again in January to spawn. So because of that change out from the coastline, fishing very near the coast, out into deep waters on the edge of the Atlantic deep in depth of winter, and during a condensed fishing period, that drove changes in the fleet as well, and there was a need for bigger, faster and more efficient vessels to be able to deliver a better quality of product at lower cost, and has resulted in the type of vessels we have today. You may be wondering why I haven't mentioned, as I think it was John who mentioned, the change in migration of the mackerel fishery up around the Faroe Islands and Iceland, which may indicate a movement northwards. I've never fished in those areas, so I can't comment on change. We hear about it, but I can't say much about that. What I do know is that the northwards leg of mackerel migration always passed through Faroese waters to the north of Faroe Islands. Where are we? To the north of Faroe Islands, and then around into the North Sea basin again. Because the Faroese fleet always had a limited fishery there and always had a share in the quota. I also know that 20, 30 years ago, the captains of Russian trawlers, the Klondikers, you may have heard of them, who arrived in Shetland to freeze or salt the herring that we were catching, often described seeing large areas of feeding mackerel up north of Shetland, from 200 to 300 miles, way up here. And of course we never went there because our boats weren't really suitable for fishing in that area, and we didn't need to go, but those things were reported. So anyway, my allotted time has well gone now, so I need to bring this together. What can I say? There have been changes, some subtle, as in the possible changes in plankton during the herring season, some more dramatic, as in the case of mackerel. Changes in migration. Are they due to climate change? Well, it appeared that way as the mackerel migration moved further and further north and east. But now it's moving steadily south again. What do we make of that? What does that tell us? Well, I don't know. And that's what we hope the scientific community can help us with. Is it something that we can expect to continue, as them to come back south again, or should we expect another change? My brother-in-law used to always say we should expect the unexpected, and that's how it's been with the mackerel. Things do change all the time. Assuming more substantial changes do take place as a result of climate change, what can be done to protect our pelagic fishery? And well, I think the first thing is already being done. The pelagic fleet is at the moment being renewed with a new class of vessels that will enable us to fish efficiently, economically, and with minimum environmental impact wherever the fish are. Whether they're in the Atlantic deeps or close to the coast, we'll be able to fish there and still be able to deliver a top quality product into the world market. Most of our vessels are capable of catching their whole year's quota of mackerel in about a month. Why is that important, and is this a crazy overcapacity? Well, it's important if our fishery, if the fish decide to stay shorter period in our waters because of change in climate, then at least with these vessels we can still catch the quotas that we have available during the time they are there. And of course it's more efficient. We use less fuel, and there are less CO2 emissions and less harmful pollutions from exhaust gases, for example. The more fish we can catch in a short period with the least energy expended makes all the sense in the world. What other changes would be suitable for us? Well, another thing that is needed is a government that listens to the industry as well as the scientific community. We both have valuable input to give in the decision-making process, and I was encouraged with our meetings with the scientists earlier today about how this has been talked about more and more, and the suspicion between fishermen and the scientific body it's beginning to change, and we see that we both need to be involved in this conversation and help each other to learn more about the stocks. We also need a management regime that's nimble and flexible, and I think it was Alan who mentioned that in connection to the Barents Sea fishery. We need the fishery rules and regulations to change quickly to take account of changes in fishing patterns. Finally, to make full use of the scientific quotas available. These are made available to help scientists and budgets to be able to do more scientific work and increase our knowledge and understanding of these key stocks and any changes to those stocks. And this fleet regeneration I talked about, that's going on at the moment, it also is bringing in new equipment like echo sounders and sonars that are calibrated and suitable for scientific purposes to help with stock estimation. And we need to be able to somehow find ways of fitting the information that the fishing fleet can gather into the scientific modelling and the work that the scientists do, both recognising each other's contribution and what we can bring to the table. And there seems to be a lot of logic in bringing the information from the fishing fleet, who are out there every day among the fish, and bringing the information they can deliver into the arena, whereas often scientific voyages are limited by budgets and just time. There's so many fish species, so many jobs they have to do. There's a limit to what can be done. So why not use the information that fishermen can supply? So these are my thoughts and observations. 44 years, I can tell you, has gone very quickly, as has my allotted time to speak. So it's time for our job to go. Thank you.
Okay, well, I think it's only appropriate after George's call for real collaborations between scientists and industry that our final presentation is being given by Steve Mackinson, who's the scientist working with the Scottish Pelagic Fishermen's Association. And so he's really there to facilitate this interaction between scientific knowledge and industry knowledge and build a lot of bridges. He's also very much promoting the use of the pelagic fleet in the collection of novel data. So Steve, welcome.
Okay, good evening everybody. Despite my name being Mackinson, I'm not Scottish, but I think I've finally come across the obvious connection to climate change in my talk. I used to work with John Pinniger and Steve Fass for nearly 17 years, and now I'm employed by the Scottish pelagic industry as a scientific officer. So you have an Englishman moving poleward, and that's the connection to climate change. So the first thing I'd just like to cover, because we've been talking about pelagic fish already quite a bit. So pelagic fish are these things, really: herring, mackerel, blue whiting fish that basically swim in the middle of the water column. So if you've been hearing that term and wondering what on earth are pelagic fish, now that's there. So I've been working now for the Scottish pelagic industry for 2 years. And while my appointment's sort of novel, it's not new. So across Europe for the last probably 5 to maybe 10 years, more and more experienced scientists are being employed by industry. So people who have experience of working in government, scientific institutions, and European arena where stock assessments performed and various forms of other sort of research. And I guess the question is, why is that happening? And the reason that's happening is that the business of fishing is becoming inherently more scientific. So science underpins the sort of information that they require, that sets quotas, so it's obviously central to their business. But scientific language just predominates all of the conversation about that. So it's starting to require that professional level of engagement in order for the industry to engage. So we've talked a lot about partnerships here, government, science, and scientists and industry. And actually, it's people like me now that are becoming that bridge and that link. So that's the kind of role that I play. So the business of fishing then, I guess science brings two things. It helps to define the environmental limits within which fisheries should operate. But it's incumbent upon science to provide the information about the management strategies that will provide and lead to, safeguard the prosperity of our fisheries. And that's vitally important in Scotland. Too often, we find that science is seen as a protectionist or conservationist, so it's believed to be that way. We have a responsibility to make, for sustainability, to safeguard the fisheries themselves and the benefits that brings to society. Okay, so why is that important? We don't have a clicker, no? We just have to come back to here. So that's important. That's the reason. That's everybody's prize, right? Fish forever. So there's our common purpose, our aim. And if we just hold that in our minds, then that's what we want to achieve. The government wants to achieve it, the fishermen want to achieve it, the scientists want to achieve it. So we have something to come together to work on. And we each have a role to play in achieving that. So my role, my new job, is to bring science to industry and to bring industry to science. So I explain and communicate. But a key part of my job, and George just mentioned a little bit about that, is the engagement of industry directly in provisioning scientific information into the system, but it has to be in a way that can receive it. And that's becoming increasingly important. So today, though, what I want to speak about is, obviously, it's a conference about climate change, and everything we do actually can be connected to this. It can be connected to a number of things. But I want to give you a flavour of my role in the context of climate change and why it's important to industry. So why is climate change relevant to the pelagic industry? You've heard many of these things before, so a lot of my talk will sort of reinforce that. Number one, fish move, right? They don't care for boundaries. We've just seen great examples of how mackerel moves. They don't care for boundaries. Biology changes. So the job, but moving management boundaries, they don't move so quickly as fish move or can move. So we have a task of both science and the management to try and reconcile those changes of how ecology maps to management and how in order to adapt to that. And climate change or patterns in movements of fish provide that as a perfect example of that problem that it creates. And it creates a lot of tension for politics and negotiation. That's Faroese Fisheries Minister teasing our Theresa May. So negotiation and wars, we've seen a fair bit of those sort of conversations about that. So we expect this to be an increasing feature, not least because of issues like Brexit, but climate change. Boundaries in the lines of management don't map ecological boundaries, so reconciling those things is important. So I'll give you an example of the kind of work that we're doing or engage with. And George already mentioned this, but I'll put a bit of flesh on the bones for it that the pelagic industry is involved with. So this is herring on the west coast of Scotland. And let me get my clicker. So we have the west coast of Scotland is defined really by these areas, ICES areas, the International Council for the Exploration of the Sea, which is 6A North, the blue area, and 6A South, 7BC. So there's these two areas. And the lines in between are really sort of, they kind of were like sort of ecological lines, if you like. And previously there was a fishery in both of those areas, principally Scottish fisheries in the north, and some Dutch fisheries involved in it, and then sort of Irish in the south. But they were different areas. There was different stock assessments for those two areas. And the fishery in the north was an MSC certified fishery until 2015, where the biological basis for splitting those stocks between the north and the south was suddenly undermined. And the stock assessment merged them all into one stock assessment across the whole area. And the result of that was a stock assessment which didn't look so good. And immediately, the fishery was closed. So overnight, from an MSC certified fishery to zero TAC. And that's still the situation we find ourselves in. But the reality was that some of the information that was required just wasn't available really to resolve that question. So it got had the potential to be trapped. So industry got involved then in putting through the European Pelagic Advisory Council a proposal together to say, let's go out and collect the data. We'll use industry boats to collect the data to put on the table to help resolve this issue. So here's an example, one of the Scottish boats, Luna Bow, some examples, and the key has been really the genetic distinction between fish in the north and fish in the south. And we've been out there for the last few years, so we did three surveys now, and the essential piece of information is these, I have to remember this now, single nucleotide polymorphisms, there we go. But the point is that basically that's the key. They're the things that are allowing us to distinguish between the two. And for 30 or more years, genetics has been promising to be the holy grail for stock differentiation identification. And I think it's finally come of its day, right? And we're going to see a lot of this in the future. Because it's become better, or for many stocks, quite remarkable, the results. So what we're seeing here, for instance, is these are clusters of types. You've got IS, Irish Sea, BLT, bacon, lettuce and tomato, Celtic Sea and 6A South. So the genetics are showing that these two fish that we know are from there are basically more similar. They're together, they're overlapping. So the Celtic Sea are close in relation to the 6A South fish. The 6A North fish are completely different from the 6A South fish, a long way off in genetic space, if you like, but identical to the North Sea. So the question we're addressing at the moment on the West Coast is this question, the difference between these and these. And we have the information. We're pretty confident, that this year we're going to get the same result. But this genetics is now going to end up opening up another bag of tricks to be addressed further down the line. And that's 6A North and North Sea. But really quite remarkable. And that couldn't have happened without industry's participation in doing the surveys and collecting the samples. And off the back of that, we're now collecting opportunistically samples are in other areas to throw into genetic studies. Let me get my sheet of paper. So the first one was fish move. That's why climate change is important. The second one is that fish productivity changes. And that's important, or let's say ocean productivity changes. But that's important because you've got big invested businesses. George has talked about the kind of vessels, and these are the kind of scale of operations that we're talking about. So these are businesses that are large investments, provisioning, and play an important role in sort of food provisioning throughout Europe and much wider. We were talking today, I can't remember the list of places that we came up with. It was Africa, Eastern European, Japan, so all over the world. So they're global businesses. That's the point. You've got Scottish mackerel is a global business, and that's provisioning of protein in an era where food security. We hear so much about fish as an important source of protein for food security. So a big issue, but it's also a big issue for other reasons. That productivity is linked to fish growth, and fish growth is linked to productivity, kind of. And what I want to show you is an example here for mackerel. Basically, mackerel are getting smaller. We've been looking over the last couple of days in this workshop for various reasons about this, and I realize this slide is going to be really simple because it's exceedingly complicated to tease this apart, and I'm not even going to try and do that. But the point is they're getting smaller. So these different colors are different ages of mackerel. Okay, so you've got over time the length for a given age, and each one of those sort of different shades is a different age. And what you can see is sort of going along. Basically, at every age group, it's heading down over the last what was that, 10 years. Mackerel are getting smaller for a given age, so they're not. So people say, why don't we see the big mackerel? The mackerel that you don't see are as old as they used to be. They're just smaller. So mackerel are getting smaller. And there are potentially a number of reasons for this, but this has a consequence for business. So I'm going to go back to the invested business. Smaller mackerel don't achieve the prices that the bigger mackerel used to achieve. So changes in productivity and changes in growth and changes in fish size have an economic impact on the industry. So understanding how those things change and affect fishing business is important. Okay, so they're getting smaller. So the reason that we believe, probably the main reason for this, is density dependence. Basically, the mackerel stocks got bigger and bigger and bigger and bigger, so every individual fish is getting kind of hungrier and hungrier and hungrier and hungrier. So they don't get as big for age. They're stealing the, competing for food. But the other reason why productivity is important is that fish like mackerel and herring play a central part in the food web. So changes in productivity cascade throughout the ecosystem. So they have effects elsewhere that are not necessarily easy to detect. And those feedbacks through the ecosystem can have indirect consequences for maybe the pelagic sector or other sectors. So it's important to understand how changes in productivity affect ecosystem changes. So where are we engaging in that kind of work? So recently, we've just successfully appointed a PhD student to work with Tara at the University of Aberdeen about fish fats in herring and mackerel and what that means. So fish fats is basically sort of a biointegrator of what's happening in the quality of the food and the productivity of the marine environment. So by measuring the fats, you can sort of use that as an indicator of, let's say, the status of the ecosystem. But what's unique that industry brings to this is that we're tapping into a data source that has never been used before. So the Scottish factories have been recording fish fat data for a long period of time for use for quality marketing purposes. And so the engagement of science has now opened up a completely new data set that's never been accessible to science before. And there might be other stuff in there as we keep digging as well. So industry engagement is suddenly switched on the light. Oh, it's just data for marketing for us. But the wealth of scientific data is there too. So partnerships are important. Number 3. So why would industry want to engage with the issue of climate change? So really, George has mentioned a lot about sort of the regeneration of the fleet and what that means for efficiency and things. Well, there's a story to tell as well. Okay, so the fishing industry, and many people know this, been demonized for a long time, the destructive force of the fishing industry. And that narrative rolls on and on and on. It's still going. How many papers do you pick up, and the first 3 lines of that paper talk about the destruction of overfishing and everything? And actually, a lot of that narrative in places is just blasé for people, so we've been indoctrinated into that. I'm not saying it's not true in places and everywhere, but for a large part, there's been a lot of change, and that needs to be acknowledged. But the narrative is deeply embedded, and that means that the industry, to take steps to be able to sort of raise their head out of that public spotlight being demonized, things like engaging in science can do that. You can just, proactively do something, put something on the table. So it's a sort of it's a responsibility, it's an engagement in science. Helps them to improve their sort of sustainability credentials. And that's important for markets as well. It's a story. If you're a buyer, what do you want? You want to buy from industries that have recognized environmental credentials. And that's the kind of thing that engaging in science does. Or certainly, that's a bit what I see my role can bring those benefits to the industry. So here's an example of how we're specifically engaging in that kind of work again. Another student actually of Tara's, Frances Sanderson, working in Shetland, and she's been measuring the carbon footprint of various food production systems. And Scottish mackerel, these are the latest figures. So from the, I think this is, it's mainly from the Shetland fleet, but basically Scottish mackerel is the lowest. So, feel good when you're eating beef and that. Lots of people know this in universities and research institutions, but I bet a lot of people don't know how tiny it is. The carbon footprint of wild capture fisheries for pelagics is the smallest. So that's a good news story, and to be able to put the information down there. So when you see pictures of like bigger boats and renewed fleet, it doesn't necessarily mean it's destructive per unit. This figure is just getting lower and lower. We're moving to electric powered winches and stuff like that. The hull shapes and things like that are getting more and more efficient. So the carbon footprint's just getting smaller. So that's a good news story. And And that's why it's a good news story. Okay. So what do we want to achieve? Well, it's a bit wordy, but really this is, I guess, the vision that underpins the work that I do and why I get involved in this work. And that's, I want to see Scottish pelagic fishermen, respected provider with scientifically credible data that's used to assess fish stocks, monitor changes in the pelagic ecosystem, and support management decisions. And what that means is that's working in collaboration and partnership and assistance. It's not about confrontation or challenge or anything. It's being part of science. And this is just to end to say, and that's what we're doing. We've started a self-sampling program. We're going through a lot of pilot work and training at the minute, but we're out there. We started with the herring season this year. We're just writing reports on the mackerel, so we're getting the crew to be doing self-sampling, so biological sampling on board, and we're writing reports about that, and we're getting spatially rich data, much richer than is done from normal sampling. So there's data streams coming, and it's not just our industry, it will be our other industry. So science needs to prepare for those data streams and say, build it and they will come. Thank you.
Okay, we'll now swap over to our Q&A session with all of today's speakers, and you keep that.
Okay.
And then Paul can come down and join us.
I'll go here. I don't know. Whatever. They should just put some shots along there. And if you get it wrong, you have to take a shot.
So you keep control of this.
I'm completely in the light.
It's on.
I'm blinded.
Yeah.
We're a little blinded.
Can't see who's speaking.
Turn that off now. We can, that'll be,
That'll help.
yeah, that's health and safety risk. Okay, I think it's going. It should. In 6, 5, 4, 3, 2, 1. Oh my God. Okay. So then it's your opportunity to ask all of these fun people questions you may have. Once again, Paul will just repeat them so that it's captured in the audio.
Someone's got to start.
Yep.
John, you spoke about dispersal of fish and climate change. I wondered if you noticed anything interesting with fecundity and fish and climate change, and if anyone else has noticed anything as well.
Okay, so the question is, what's happening with fecundity and climate change?
I think Tara's probably the best person to talk about this, actually. But we have seen changes in the timing of well, not overall fecundity, but changes in the timing, so phenology, that different species spawn and build up their reproductive organs. So things like sole are moving earlier in the year for most of the stocks in the North Sea. But I think Tara can probably say more about that than most people.
So just a definition, fecundity is the amount of eggs that fish produce, and phenology is the time of the year that they produce them. Yes?
I'm wondering that so much depends on predicting the future and the use of all those wonderful models on the habitat variables that you use as being the important ones to species, and I'm wondering how much have the industry and scientists been talking together to think about what are those important variables, i.e. the idea of red feed that George brings up. Is that conversation going on, or are we still just using surface temperature, distances from shore, all that stuff.
Okay, so the question is, when developing habitat models, how much is industry working with the scientists to kind of define the variables?
Me, okay. I mean, there is some discussion. People are throwing a whole suite of models at these things. So for example, we were talking yesterday that these sort of species distribution models that I briefly mentioned do a terrible job of mackerel. And it's because it's so complicated. They have a very complicated life cycle. They migrate over huge distances. They have all sorts of environmental influences. So you need a more sophisticated model for that species. Sometimes these species distribution models do pretty well. And for most of our species, they do okay. But for things like mackerel, you need a more complicated model. And so then we have to have these discussions about, well, what's really driving it? Do we have the data? Can we get the data? And so, yeah, it's horses for courses, really. Anyone else? Yeah.
Yes, Peter.
Right. I was going to add, Paul. Okay.
Oh,
sorry. One quick follow-up. So in Alaska, actually, with the Gulf of Alaska marine heat wave, you had this experience where actually fishermen, experienced really bad fishing conditions before we didn't have a survey that year, and we didn't react. It wouldn't really have changed very much in what actually happened, but it basically set off an alarm for us that we talk to fishermen a lot, but we're not systematic enough of making sure that we're getting that information to the right people as quickly as possible. So actually this winter, we're going to have a process where we review the way that the information that we have and then try to make that automatic.
Okay, Peter.
So following on from what Beth was saying about the way we model, I liked your talk, John, but one of the things you continued with this idea of fish moving north, moving deeper, and you gave the example of North Sea cod, which we know now there's no such stock population as North Sea cod. We have different populations that undergone different changes, have been subject to different exploitation. And there's also been recent papers this year in Frank's work on eastern Scotian shelf cod, where they're explaining some of the changes more to do with exploitation patterns than to do with climate change. And George, I think, continued this on very nicely when he was saying the herring, with the herring story, we know herring, like cod, have this quite complex population structure. They're not seeing any changes in the pattern of distribution of herring. So I think, don't you think we need to move in terms of our complexity and understanding and be careful about these terms like fish moving north, moving deeper?
Okay. I'll try to summarize the question. So as we see variability in fish distributions and how they change over time, do we need to have kind of more complicated ways of thinking about describing this variability? Does that capture it, or?
Yes, and including a better understanding of what we're actually dealing with. We saw in the presentations there with herring, we call West Coast herring as West Coast herring, where we know there's actually at least two populations, a northern and a southern population. So taking into account what we're actually dealing with, I think is really important.
Right. So getting at the question of how much of changes in distributions are due to changes in different types of stocks moving in different areas.
I mean, to go back to the cod example, for example, I absolutely agree. And it's a bit of a cartoon just saying things are moving north, very much so. That there's all sorts of things going on there. Firstly, there's different subpopulations in the south and the north, and part of it is driven by exploitation, where the ones in the south have been more heavily exploited than the ones in the north, and so they've declined more than the ones in the north. And so what looks like a northern shift is actually an emergent artifact of the data often. But the models do suggest that things are going to generally, also the temperature of the North Sea is a bit of a cartoon too, that actually in the winter the southern shallow areas are colder than the northern ones, and so it is a cartoon. And so yes, we do have to be
more sophisticated, and a lot of the modelling in reality is more sophisticated than that. But then we also are looking at the genetics and some of the issues that Steve talked about. There's a lot of work going on, but for convenience we often talk about, wrongly, this northern shift.
Well, I'd say it isn't wrong, and that generally speaking there is this pattern of species moving north in the northern hemisphere and south in the southern hemisphere, but of course the devil is in the detail, and that general pattern doesn't mean that we still don't have all these more nuanced influences and changes, and we shouldn't forget that. And of course patterns of exploitation, habitat loss, there's a whole lot of other influences that affect species distributions, and those influences don't go away just because we have this overarching influence of climate. But that particular paper that you mentioned, the Frank et al. Paper, there's been quite a few rebuttals written about that paper, and I think their paper was an excellent reminder that exploitation can have very significant impacts in the marine system, but their paper didn't actually suggest, or shouldn't have suggested, that fish aren't moving deeper because of climate, and Alan could probably provide a more detailed rebuttal to that comment.
Well, I mean, just to expand a little on this theme of the movement of fish, quite a lot, and we've had some anecdotal stuff saying this today, quite a lot of the species have tide spawning areas, and those spawning grounds are actually not moving because they're tied to geographical features like gravel banks or certain areas. So the abundance of fish in some of these areas may be going down due to climate change or exploitation or a combination of the two. There can be movement outside of the spawning time, but the fish are still trying to come back to those historical spawning grounds because they're homing back to those, and that complicates the position as well.
Okay, so the comment was that perhaps you have fish that are somewhat static in their spawning grounds, but they might move at other points of their, of their life cycle.
Yes, there's a lot of truth in what you're saying. The herring are territorial when it comes to spawning. They come back to the same spawning grounds, but we don't only see the herring when they're spawning, we see them all through the year, and we really don't see any change in their natural habits, what they do throughout the year, not just at the spawning time. We don't see any significant change in the habits of the herring. There may be some significant change in the size, although we don't really see that either. So I get your point about, and it's a good point about the herring returning to the same spawning grounds, but you would think that there would be other changes, but we don't really see that.
Yes.
So just an overall question. Two of you mentioned here in Scotland, squid is on the rise, and in Tasmania there's a new species of octopus. So if the shifts are happening to the more north or more south, are there other species that are taking the place of the fish that are leaving? Is there still that mobility for the fish to return, or is it the entire ecosystem that's basically shifting more upwards?
Okay, so the question was, as fish kind of move to the poles, are they being replaced by other fish?
Because not all species are moving at the same time, because of some of these nuanced changes that we've already mentioned, there are a lot of links in terms of predator-prey relationships that are being broken, but so the ecosystems are not moving neatly all together, which is why there's some of these really interesting responses and changes. But the squid question is a really interesting one. So squid have a very short lifespan of a year or 18 months, most species. They're very ferocious predators. They will eat almost anything that's moving. They're more flexible in terms of the size of things that they eat. And there's been a couple of good studies recently. One was by an ex-PhD student of mine, Zoe Doubleday, and she analysed cephalopod populations all around the world, and there was a pretty strong suggestion there that cephalopod populations, so that's squid, octopus and cuttlefish, are increasing in abundance around the world. And so that doesn't surprise me that they're one of the key species that we are seeing move around the world, because they are such just flexible, plastic, adaptive animals that kind of can move in and take off when other animals have decreased. Did you want to have a...
Yes.
This is a question more about adaptation governance, because sort of leading on from that issue of species distribution. I mean, fisheries is such a dynamic resource, and to what extent in the future do you think that the boundaries of territorial seas and the exclusive economic zone might inhibit the adaptation of the fisheries industry?
Okay, great question. So our management boundaries in the sea, to what extent do they inhibit fisheries now or in the future?
I'm not sure which way to come at this from. I think you might have the wrong panel in front of you for that question. So I'll start with that. You probably need someone from policy. The inhibitor will be the speed, the speed of change. How quickly can you make agreements to adapt to changes in species distribution that matter? We just talked a little bit about this changing species with the octopus, and what occurred to me there was, I don't even know if it's a valid question, but the issue of reversibility. The ecosystem changes. Can it go back? Is it a one-way trip? And then if there are situations like that, so to bring that question, whether it's invasion dynamics or succession, and whether it can go in either direction, to bring that into the context of how can management and boundaries adapt. If it's a one-way trip and you know those things, then you need to adapt management to suit.
I mean, the squid example is particularly interesting because it's a non-quota species. So the fleets could target squid, whereas they couldn't switch to other species which have tight quota restrictions. And so there is an element there of we have both spatial boundaries, we have quota boundaries, all sorts of governance restrictions. We also have issues of closed areas where we're predicting temperature changes, and so the species that we're trying to protect might no longer be in the closed area. As you say, governance isn't quick. It takes a long while to adapt governance, and so, but it's political. It's not something the scientists can necessarily do anything about. It has to be the politicians.
So in Alaska, both pollock and cod have shifted north a little bit in the last several years, or quite a bit. Some out of the U.S. into Russia, but pollock has done moves into Russia and has for a long time. So there's been some fishing pressure, but it is something that over time, I think a lot of these agreements are going to have to see. The rates of shift matter. And I think, John, I think there is a lot for science to offer here in trying to make sure that policymakers are realistic about how that's going to happen. And in some cases, you may have good management on both sides, and there may not really be a threat of overfishing if it's conservatively managed in both places. But in other cases, it really may be important that you have new agreements or new focus on trying to resolve and understand the amount of fishing effort happening in different places. So I think there's a big role for science to play in making sure that policymakers understand the processes that are happening.
Yes?
George and Steve, you made a comment about industry and science working together, and I wondered what the feeling in the industry is towards remote electronic monitoring. I think it's a good opportunity for industry and science to collect a huge amount more data, acoustic signals, fishing efforts, spatial distributions of fish.
and sort of resolve some of the differences between industry and science and what each is seeing.
Okay, so the question is, how does the industry feel about remote electronic monitoring?
Are you talking about onboard cameras or?
Sort of sensors,
Picking up what we see on our echo sounders and that
yeah,
sort of, yes.
GPS.
I think that makes a lot of sense. So already our ships are subject to VMS. It's what does that stand for again? Vessel Monitoring System. And so they're watching where we are and what we're doing all the time, and we have no problem with with a scientific body or anyone else getting access to the data that we see in our sonar screens or echo sounders. So no issues with that. We have some slight issues with cameras on board. Nobody likes to live with a camera pointing over their shoulder, and although it might not just be quite like that. And our policy in the pelagic fleet is at the moment is that we'll be happy to accept cameras when every other country fishing in our nation, in our waters does the same. We don't want to see our fleet having to have cameras on board when other countries' vessels can come into our waters without those on board. So that's the official position of the Pelagic Fishermen's Association. Does that help to answer your question?
Yeah, I think the possibilities for, and I'm glad you used the term remote electronic monitoring in its widest form, because it's just been associated with cameras, and of course it's not. The possibilities are actually quite enormous, but overwhelming at the same time. So I have quite a lot of experience with acoustic work, and we can calibrate vessels, and we can do that quite easy now. They have scientific grade equipment, so we could quickly fill your boots with acoustic data. The question is how, and it has been tried, how do you mobilize that data to make it useful? So we could overwhelm, the science community with data. So you've got to come with a good question. What's the problem first? Is this appropriate? Is this an appropriate tool to address that question? If acoustics is, then then I think it can be done. And certainly, our industry is open to that. Quite often, my WhatsApp box is filled with a snapshot of a screenshot, like, where are you? Look at all the fish we're seeing or something. And we can capture that and record it. Hard disk space is cheap now, but it's the time it takes to do something with it. There's all sorts of other, future electronic monitoring things as well for automatic measuring, identification. Identification is not really an issue in our fleet, but certainly other fleets. Automatic identification, measuring and stuff like that. Loads of scope still for that. And that probably is, the future of younger scientists to be handling that kind of data, big volumes of data.
Okay, so I think we have the room till 6, so maybe we should take one more question. And Margaret, yes.
So I'm a representative of the Gaudi student newspaper from the University of Aberdeen, and I have a question for Stephen and for George. And I hate to bring it up, but a lot has been going on in fisheries and Brexit, and I wanted to ask you if you still see, because I know as a representative from the organisation, the Scottish Pelagic Fishermen's Association, which endorses the idea of opportunities in Brexit, I want to ask if you still see these opportunities now, given the recent developments that the quotas definitely won't change before 2020 and after 2020. The measurements of the quotas will probably not change, and also, as we've heard before, most of the fish we import is the one we eat, and the one we export is the one we don't eat. And even if we were to leave the European Union and the single Union and the customs union, we then have to face tariffs on the fish we export and then take tariffs on.
Okay,
so I respect your question, but I'm not going to answer it. And there's a reason for that. There's a clear distinction in my role. Okay, I'm employed as a scientist for the industry, and I don't get engaged in the political side of it. That's my boss's job. He's the CEO of the organisation. So it's just really not my remit to have an opinion on that. And we're here for a scientific conference, so I'm not going to answer it because I may have a personal opinion, but it's not my role as a scientist for the association to do that. Whether or not George has an opinion is up to George.
Do you have an opinion?
Yes, I've had an opinion about most things. Brexit's definitely one of them. Yes, perhaps Brexit conversation isn't going the way that we would have loved it to have gone. And it's not that we want to fall out completely with our European neighbours, but there are benefits to the industry, apart from increased quotas from being out of the EU. One of the things we have highlighted today, and not just myself, was how difficult it is to change legislation and rules when you're part of an organisation that has 27 nations in it. How difficult it is to change the parameters to take account of changes in the fishery. One example, I talked about the movement of mackerel and how it eventually ended up at one point for years in the Norwegian sector. And we had no choice but just to patrol the edge of the Norwegian sector, hoping that a few mackerel would migrate across briefly into our side and we could catch a few. And that was the situation for a long time. It was a difficult time. And we were pushing our government, saying, look, we need to get access to the Norwegian area. We need to get access to the Norwegian area. It was impossible to achieve, even though the power of the EU was there at the negotiating table. When the mackerel changed their habit and didn't go into the Norwegian sector, the Norwegian fishermen, of course, went in the opposite direction and said, look, now we need to get access to the EU waters to catch our mackerel. It took them 1 year because that nation talks for itself and it is able to decide what's best for its own fishermen without having to get the cooperation of many other nations who have completely different agendas. So that decisions are made not because of the logic of the decisions, but because that was the only consensus that could be achieved in the EU forum, if you understand what I mean. So that would be one benefit I would hope we get out of being a coastal state. And I think from the conversation we hear coming from Downing Street and from those that are working in that area is that we will end up as a coastal state. And hopefully we will be able to decide some of these things for ourselves in the interest of our own fishing community. There was something else I was going to say, but it's gone. Maybe it will come back. Is there anything else you want to ask about that? No.
Have you got something for the paper?
As regards increased quotas, the quotas will be decided in the same way as before by ICES. They will decide what a TAC should be. What we hope to achieve is that a fairer share out of quotas will be achieved in the long term. We're not saying that every other European fisherman should be excluded from our waters from day one, but we feel some things are a little bit unfair and biased towards some of our EU nations. So.
Okay, great. Well, please join me in thanking our wonderful panel today for sharing their time. Okay, I'd like to thank again Fisheries Innovation Scotland for providing the funding to get this event up and running, as well as this many wonderful scientists. Now, you've met some of them through this afternoon's presentations, but I'd just like to take a little time to introduce everybody else who's been in Aberdeen this week. So I'm going to run through, and the reason I'm doing this is because we have a reception afterwards, and it would be just wonderful if you collared them and asked them whatever burning questions you have about fish, about climate change, or just about where they live. They come from some pretty cool places. So I'll go by name and just have a little, stand up and wave at the audience. So I'm going to say Tom Helser, our question generator of the week from Seattle. Melissa Hulda, also from Seattle. There, thank you. And Christine Stewitz from Seattle, University of Washington, if you're Pierre Bogstad from the Institute of Marine Research in Bergen. Einar Hjorleifsson from the Marine Institute in Reykjavik. We've got Robert Ullman, and he's from beautiful part of the world, Florida Panhandle, Panama City. Daniel van Denderen from Denmark. Bryony Townhill, Bryony from CFAS down in Lowestoft, and Myron Peck from the University of Hamburg. So please do circulate when you join us in the reception. Okay, so I think we've heard a lot today, and I want to thank all of you for turning out, and a particular thank you to the people who've asked questions. Please keep asking questions, and please keep engaging with scientists, because we just love to talk about our science, in case you've noticed. So thank you.